big questions about the universe fascinate us all. Could humans one day build wormholes or time machines? Could life exist beyond Earth? These mysteries drive our love for astrophysics and cosmology. But here's a reality check. Life as a space scientist is never glamorous. It's actually years of mathematics, coding, sleepless nights of research, and the perseverance to keep going when the answers are not even there. Cosmology, for example, is like building a house. So without proper foundation in physics, mathematics, and problem solving, it all collapses. And yet, if you have ever looked up at the sky after watching Interstellar or felt goosebumps after hearing about Chandrayaan 3, Aditya L1, or India's Gaganyaan astronauts, so you already know that this path is worth pursuing, because behind the tough equations and data are discoveries that change how we see ourselves: water on Mars, black holes colliding, the first image of our galaxy's heart. So in this video, we are going to break down the complete roadmap: who astrophysicists, cosmologists, astronomers really are, how you can become one in India and abroad, the institutes, exams, jobs, and even the salaries. Most importantly, we'll show you why these fields are not just about stars or aliens, but about understanding life itself and India's future in space. So stay tuned till the end, because you're going to know about lots of domains and professions. So hello everyone, my name is Saumil Prakash, and let's deep down in career options in space sciences by SciAstra. So the first one to start with is, of course, very popular, everyone knows, the favorite of most of the students, astrophysics, or the people who pursue are astrophysicists. So ever wondered who studies black holes, galaxies, and the birth of the universe itself? That's the work of an astrophysicist, the scientist who push the limits of what we know about space. These are the tools and types, okay, so they can be theoretical, they can be observational, okay, so who actually use telescope, use data analysis to analyze all the data that we're getting from those telescopes, and of course they conduct and facilitate the missions related to space as well. So path is typically you can pursue or start from BSc in physics, followed by masters, and then PhD in institutes like IOCA, IIA, IISRS, TIFR. These are just the institutes in India. There are very popular institutes in abroad as well, such as Max Planck and other reputed universities such as Harvard, Oxford, MIT, etc. Real life impact is somewhat you can work in imaging, analysis, navigation, and these days AI getting very popular. So that also has a huge impact when combined with astrophysics. Salary, of course, ranges from 5 to 10 to 12 lakh. India, 40-60 while doing your postdoc. What is a postdoc? A research position that you pursue after finishing your PhD degree. So that will give you 40-50 lakh rupees per annum. So that is abroad in countries like USA and other European countries. 1 crore plus, 1 CR plus, the dream number. When you become very, very, very popular, very lesser number of people actually get this amount, but who get this amount are actually very popular, and they get huge recognition as well. So we'll talk more about people who actually make this kind of a money. You probably know them as well. Next one is astronomer. So imagine being the detective at the night sky, tracking planets, comets, distant galaxies. So astronomers are the people who decode the secrets hidden in the light of the stars, right? And this is what they do: comets, galaxies, space detectives, as they are called. Projects are, some of them are AstroSat, Aditya JWST, James Webb Space Telescope collaboration. They are actually responsible for conducting those observations, those sessions, okay, via institutes like Indian Institute of Astrophysics. If you know where IIA is situated, let me know in the comments. IOCA Pune, PRL, Physical Research Laboratory, IISRS, NISRS, CEBS. And these are the institutes, of course, where you can pursue your degree after class 12. Okay, so your basic science research degree. We'll briefly talk more about these at the end of this video. And path is you can start with your BS, MS, then PhD, followed by postdoc and further research position to make money like 6 to 20 lakh rupees per annum in India when you actually get a job. And of course, abroad has a bit higher stipends and corresponding salaries. You can predict your ellipses. What is ellipse? So let me know what is the significance of ellipse in astronomy and cosmology, right? So it has a very deep significance. In fact, the trajectory, the orbit, I'm not going to talk more about that. Let me know in the comments. So you can protect satellites, track them, asteroids, meteors, comets, all those things. Next up, we have cosmologist. So what is the universe made of? Where did it begin? Where is it going? Cosmologists, are the people who are responsible for finding these answers. They try to find these answers to the biggest questions about the existence of the universe, right? So this is what they typically do. Skills are advanced physics, of course. A lot of mathematics is needed and used in cosmology related to relativity, special theory of relativity, general theory of relativity, quantum mechanics. Topology is also used. Okay, if you know topology, then of course, salute, respect. And institutes are typically the institute are pretty much same. TIFR, IIA, IOCA Pune, IISRs, NISR. So wherever there is a department related to space sciences or astronomy or cosmology, most probably there are research groups working in fields like cosmology, quantum gravity, string theory, astrophysics, astronomy, and of course, planetary science as well. Of course, it matters, depends on the particular institute, what kind of department they have. For example, NISR, where I pursued my degree from, they had a separate department for earth and planetary sciences, and in that EPS department they used to do lots of planetary science, data analysis, some amount of cosmology. Whereas in the physics, School of Physical Sciences, they had people working in quantum gravity, relativity, cosmology, whereas astronomy, space science, planetary sciences was more restricted towards EPS, Earth and Planetary Science Department. So it varies from institute to institute, but pretty much they are the same. So climate science, of course, is a byproduct. And salaries similar to astrophysicists and astronomers. By the way, that many of the tools and techniques that are actually developed by people working in cosmology, astrophysics, to use the large data sets, gathered by satellite observations and spectroscopy. So those tools in data analysis and other things are often used in other fields, such as techniques used in AI, finance, climate sciences as well, right? So to analyze and gather insights from those huge data sets that they typically get. So next up is astrobiologist. Very interesting, interdisciplinary field. So have you ever wondered that are we alone in the universe? Most probably you do. So could life exist on Mars or oceans hidden beneath Europa's ice? So astrobiologists are the people who are responsible for these sort of explorations of life beyond Earth. So this is what typically they do. And what is the thing that we need to do to figure out if there is life exist or not, right? So for example, if you're able to find carbon, it's an indication of life because we are all made of carbon, right? So it all started with carbon, C12. If you're able to detect any of it anywhere, of course, it's an indication. Another one can be water. Water is the broader thing that we look for on surfaces of Moon, Mars, etc. Right? If you know the relevance of finding water or carbon, then let me know in the comments. Of course, we do read each of your comments, and if something is very sensible and logical and you demonstrate your knowledge, of course, we will like it and we will project it to other students as well. But fields mixed, interdisciplinary, involving bio, chem, astro and geology as well. Institutes are typical. Path is you start from bachelor's, master's, PhD, postdoc, research positions, observatories, so on and so forth. Salary is typical. Impact is, of course, huge. You do get to work related to biotech fields, water recycling, medical sensors, and many more, right? Because you are working on some chemistry, some, of course, biology. You're studying about organisms, how it all began, about life, planets, space, celestial bodies, right? And of course, you are putting it all together to figure out the existence of life. Next up is planetary scientist. So have you ever wanted to work on missions like Chandrayaan or Mars rovers? So planetary scientists are actually the people who study the planets, moons, asteroids to understand how worlds are born and where we as humans might live in the future. Okay, so this is what typically they do. Of course, includes studying comets and other projects such as Chandrayaan, Mars rovers, JUICE via these projects to study these phenomena and bodies. Now, skills are, of course, physics, chemistry, some geology, sometimes biology, mathematics are also required depending on what are you actually working on. But these are the institutes. PRL, ISRO specializes, the research groups, the people, scientists working over there in space science, data analysis, remote sensing, and of course, exploring about life on different planets and bodies. Right. IISc, EPS, Earth and Planetary Science Department. Remember, I just talked about IISERs, IISER, etc. The real life impact is we derive these tools and learnings to study moon bases, Mars missions, and eventually asteroid mining as well, which is not the thing of the future. It's actually being explored right now. Okay, and you might get to see this happening in the near future as well in the upcoming 3, 5, 7, 10 years down the line. Salary is typical. Abroad gives you some higher money, naturally. Next up, we have aerospace, space engineer. So from rockets to satellites, every machine that goes into space is actually built by aerospace engineers. So if you have ever dreamed of designing the next, let's say, ISRO's Gaganyaan, this is your path, right? It's a bit different than the basic science research path that we have just talked about, astronomy, astrophysics, cosmology. But here it is, they build rockets, spacecraft, propulsion systems. So, going into the technicalities of the machines, how each and everything is going to be executed in missions like ISRO's RLV, SpaceX Falcon 9, very popular. Path is you start from BTech rather than BSc because you're actually applying those learnings, those engineering, to build machines that does those jobs on landing on different planets, doing different analysis, collecting soil samples data. So you start from BTech in aerospace, mechanical, electrical. Then of course you go on to pursue your master's, PhD, so on and so forth in institutes like IISc Trivandrum, IITs, ISC Bangalore, so on and so forth. The real life impact is you can work and you can comprehend the areas of affordable rockets, global GPS, remote sensing, cheap internet, of course, is a very wide application of satellite building and aerospace engineering. Salary, of course, is typical. Abroad gets you higher money if you join organizations such as NASA, European agencies, or Japanese agencies, for example. Next up, we have satellite and space tech specialists. So right now we are moving more towards the applied engineering or technical part of space science, right? So they usually work on communication, weather, navigation satellites like GPS, IRNSS. But for example, our phones, maps, weather apps, so everything, all depend on satellites that we have up there. So a specialist in this field, they actually design, launch and manage all those things that are above us. So applications are remote sensing, climate defense. Defense is also very important. Institutes are typical. Of course, IRS, Remote Sensing Institute, Dehradun is also very significant here. IITs, ISRO Space Application Center is also there to train you. And you start from BTech in electronics or computer science. Then, of course, you go on to pursue MTech in remote sensing, space communication, or AI. Okay. Real life impact, like I just mentioned, you can use it in defense. You can predict, weather and of course, eventually floods, drought, those things to boost agriculture that goes on in a country. That is why sometimes it's very important to have your own satellite, right, launched and your own GPS. So does India have its own GPS? Do you know about it? If you do, then let me know in the comments. Yes, no. If yes, what is it? If no, why not? And connect villages, of course. Salary again is typical, similar to the space engineers. Or next up, we have space data scientist, right? So modern space science actually includes huge amount of data, okay? And it ranges in terabytes, okay? From telescope, satellite, spectroscopy. And these guys, space data scientists, they actually use AI data science tools to turn that data and gather insights from all those by cleaning, analyzing, and doing other important things. So handle massive telescopic data and use those computational tools, AI, ML, data science, querying, big data, cloud computing. You start from BS and then go on to pursue MS in typical institutes. Salary is also very typical. And the real life impact is, of course, very much important. These skills can be transferable to artificial intelligence because that can be used on the data gathered by all those telescopes and satellites to produce meaningful insights which can be impacted, which can be used to create impact in healthcare, finance, fintech, and many other fields, okay, such as healthcare, defense. Next up, we have space instrumentation engineer in a particular mission who is responsible for building that particular payload that is going to be carried with the satellite, and with every telescope, every probe, every rover that we have. They all have very delicate instruments, and all of it have to be put together very delicately and properly function so that the missions are executed properly and meaningfully, right? So camera, sensor, detectors, these engineers actually build these things for space exploration. This is what they do. This is the path. You start from engineering. Sometimes physics is also required, but MSc MTech is the way to go. Institutes are typical. Real life impact, you can, of course, engineer equipments for medicines, health. What is LiDAR? Okay, let me know. Optical sensors, of course, are very important. Salary is typical because what you get as an engineer. Next up, we have space robotics and AI engineer. Of course, with AI booming, it's gaining popularity these days as well. And the thing, not of the future, but the current, and of course, leading us towards the future. So think of Mars rovers, robotic arms on the ISS, robotic engineers. They design these machines that go onto these satellites and exploration devices where humans cannot. And artificial intelligence actually is making all these devices smarter and smarter day by day. So this is what they do. Path is you start from BTech, MTech is specializing in AI, data science, okay, and robotics. Institutes are typical IITs, ISRO labs. Sometimes DRDO labs also work. Impact is you can make autonomous rovers, AI-driven telescopes. Okay, suppose you have AI-driven telescope. It has all the data fed based on the previous experiments that have been conducted. It knows what kind of data to gather, what kind of data to look for, where to look for exactly. Just imagine what kind of things we'll be gathering and using those AI and data science tools, what kind of insights we'll be getting into space exploration, right? This is it. Next up, we have space material scientists. Of course, very, very important. Space is very brutal. Lots of things, heat, cold, radiation, emission. Material scientists are actually responsible for creating those materials such as alloys, those shields, suits that the astronauts are going to wear that protect them and that makes those spacewalks, those missions possible, right? This is what they do. Path is, again, very typical. Institutes are typical. Impact is you can make stronger rockets, and since you are expert in material science, you have huge opportunities to work outside as well, right? And build those machines, materials elsewhere. Okay, safer spacecraft is what you will be contributing towards. Next up, we have space medicine specialist, right? So who is going to take care of the astronauts' health when they're out there in space, right? Something is off, they're not well, they're sick, and what do we expect them to gather that can be used and analyzed to derive meaningful insights from all the data we have, right? So it can be from radiation or bone loss. There are various health challenges that all the astronauts face while being in space on a mission, right? So space medicine experts actually protect their health so that we can live and work beyond Earth as well. This is what they do, keep astronauts alive, simply. Path is start from MBBS. You're technically having a doctorate degree from these institutes, IF Institute of Aerospace Medicine. So DRDO also have established departments on space medicine, and ISRO Gaganyaan team also specializes in that. Real life impact is very important. You can create, waves in health tech, wearables, telemedicine as well. Okay, that is going to come, okay, in next 5-10 years. Salary is typical. You can get higher and abroad because you're a medical specialist, you're a doctor, some tech as well. Okay. Next up, we have a science communicator. Do you know this guy? Have you heard the name of him? I guess many of you do know his name. Let me know in the comments. But he is a science communicator or a space educator. They are scientists themselves. And have you think that people like Carl Sagan or this guy or sometimes your favorite YouTuber, these are the voices that actually make space explorations and those phenomena sound exciting and accessible to everyone, the masses, the common people in their households who don't even know what astrophysics, cosmology, and robotics is, right? So a space communicator actually inspire millions of people. I believe, many of you interested in astrophysics or cosmology might be inspired by these guys, right, in your childhood by watching their shows. So this is what they do, more accessibility to people. Path is, you can have any science engineering degree. You need to be an expert in communicating science to masses, basically have storytelling, good knowledge, and connect with people, right? Institutes can be typical anywhere. Impact, you can inspire the next generation of scientists, right? And salary is very much varies from 6 lakhs entry salary in India if you're working with organizations such as ISRO or any private firms, or if you're a creator or educator on yourself, you can make much more, like 50 plus LPA for top educators and creators in India or abroad. Next up, we have astronaut. Okay, they work on space stations, moons. They are the people, right? The suits that those specialists are making, those medicines that these doctors are making, these spaceships that those engineers are making, everything is used by those astronauts. For the people who actually go on those missions, who fly spacecraft, who land, who collect those samples, who gather those data, right? So the dream of everyone, probably the dream of all dreams, to live and work in space. So astronauts are the people who are trained to survive the impossible atmosphere outside, to walk on moons, and someday even on Mars. Okay, so this is what they do. Training is including piloting, survival, robotics, spacewalk, but not limited to just these. Of course, you need to have a technical degree as well. In India, Gaganyaan program, have you heard about Subhanshu Shukla? Okay, so he is an astronaut. Okay, so he was used to be an IF pilot, then trained, have a master's degree, and right now, a Gaganyaan pilot. Eligibility is science engineering degree with support from Air Force, ISRO, and fitness should be very, very extreme. And salary does not matter at this point, because the recognition, reputation, fame you will be getting will be immense throughout the world. Just like Subhanshu Shukla did. And we already have made a full video on him, what he have done, his story, his life. You can go check it out. So salary, of course, is less important here. But the real life impact that you will be making will be related to something called as microgravity experiments. And the real life impact that you will be creating will be used in the fields like medicine, AI, materials, by something called as conducting microgravity experiments, collecting again data, samples, analyzing it to produce meaningful insights. Now we have a space entrepreneur. Okay, so this is going to come as space is going to become more and more accessible, affordable, although that is a question, and technically possible. More and more people it's not impossible. Okay, 5, 10, 15 years down the line, space tourism will be going to explode. Space entrepreneurship will also boom. Okay, so you will be building startups, launching satellites, AI for space, or even you can also build some data analysis tools or small SaaS software or some hardware that can be used in space travel or space missions, right? These are some of the examples. Skyro Technical. These are Indian companies, by the way, Indian startups, okay, building rockets and components. So any engineering science degree, but you should be very passionate. You should have a knack for problem solving and build things, right? Support our In Space and ISL Startup India. So if you have the right talent, passion, and grit and perseverance, of course, people will find you, government will find you, agencies will fund you, and you will be able to make an impact. Of course, make space cheaper, accessible, and help conduct those space-related missions. Now, the final summary or the takeaways is that the direct entry paths are via institutes such as IISER, NISER, IITs, IST, ISC Bangalore, PRL, IOCA. Although these are the institutes, first 5, 6 are responsible for, they offered you to pursue undergraduate degree, meaning after class 12, you can take admissions by qualifying IISER aptitude test, NEST for NISER, IIT JEE Advanced for IITs, and similarly IST as well. Then after your bachelor's or a master's degree, you can pursue PhD. Okay, so these are the true entry points for research or scientist. Now, engineers can join ISRO directly or industry after their BTech or MTech. Of course, these guys, the BSMS students also can join ISRO by qualifying their examinations. Okay, but opportunities are comparatively a bit more for engineers, and real life applications are huge. Like I just told you, satellites, health tech, fintech, space, GPS, AI, agriculture, defense, climate methods, medicine. And with ISRO's rise via missions like Chandrayaan, Aritel-1, Gaganyaan, the next decade is India's golden opportunity for space-related careers. And you should take definitely advantage of this upcoming wave, because if you are in school right now, class 10th, 11th, 12th, dropper, or even pursuing your BS, MS, okay, this is the thing for you, okay, because you have the opportunity to create such an impact by pursuing your research degrees. And if you dream of becoming a scientist or pursue any of this, it can be possible by joining these institutes, which are called basic science research institutes, via exams like IIT, NEST, IISc, etc. If you're preparing for IIT, NEST, IISc, or any of these research-based examinations, then you might want to check the courses that we have: Homi, Vikram, Raman, and Kalam, depending on you're a dropper or a class 11-12 student. And if you want to know the top 20 research institutes in India, you can check out this video. And this presentation, the PDF file of this, will be available on SciAstra's free materials section, where you can directly download this and use it. By the way, I hope that this video has been helpful a bit so far. If you have come this far anyways, put a subscribe and a like, and share with all your friends who dream of becoming space scientists. With that, everyone, see you in the next video. All the best. Bye-bye.